In this video, we're going to look at yield and defect metrics. There are two tabs in the downloadable file, and on the first tab, we're looking at the yield metrics. Let's suppose we have a three-step process, and we'll look at the performance at each process step, and then ultimately we'll look at the performance of the entire process. Anywhere you see a yellow cell, remember it's asking for an input, and so we'll use an example of 100 units that were submitted into process step 1. And we'll assume that 15 of those were scrapped, and we needed to rework 5 of those. And we can see immediately that the final yield for the process step 1 is 85%, right? Because we've got 100 units in and 85 units out. The 5, of course, are included in the 85 because we reworked them, we didn't scrap them, but we lost 15 to scrap. So we've got 85 coming out of the process and 100 going in, so it's a final yield of 85%. The throughput yield is 80%. Now I have to take out not only the 15 for scrap, but also rework, so that's part of my throughput yield. My roll throughput yield, because I am talking still about step 1, is still 80%, and then we've got the normalized yield. Now I've got 100 units that went into step 1, I've got 15 units I lost to scrap, and so automatically 85 are introduced now into step 2. And let's suppose that 10 in step 2 I scrapped 10 and I had to rework 8 additional units. My final yield is 88%. My throughput yield now is 79%. And when I multiply 80% and 79%, I have a roll throughput yield of 63%. I had 85 units, I lost 10 to scrap. That gives me 75 units going into step 3. And then carrying on the example, I've got 20 that I scrapped in process step 3 and maybe 1 that I reworked. And so for this step, I've got a final yield of 73%, a throughput yield of 72, and a roll throughput of 45. And then overall, for the three-step process, I have a final yield of 55%. And the final yield is the number of units out versus the number of units in. And then the roll throughput yield is I simply multiply these three numbers, the throughput yield, 80, 79, and 72. When I multiply those together, I get 45%. And that gives me approximately 0.79 defects per unit. So that's how we calculate yield metrics. Now going over to the second tab in the file, we've got defects, and the example I'll use here is, let's suppose we have 500 units that we're examining. And we've got 7 opportunities on each unit. That gives us a total of 3,500 total opportunities. And then let's suppose we've got 20 that are defects. And if that's so, then we've got 4% DPU, defects per unit, about 4%. We've got DPO, or defects per opportunity. So this is per unit, talking about the 500. And this is per opportunity, talking about 3,500. So that's the difference in the number here. And then we have a DPMO of 5,714, also known as ppm, or parts per million, but commonly it's DPO, defects per million opportunity. And then we've got a short-term z-score of 4 and a long-term z-score of approximately 2.5. And that's it. That's all there is to calculating defect and yield metrics. This template is downloadable from the sixsigma.org website. There are other resources there as well. And thanks for watching this video.